So moving on to that last structure, structure D, what we want to do again, survey our lineup, find molecules that have the same connections of that terminal carbon. So the carbon is going to be at the end of the chain, bonded to two hydrogens, followed by a nitrogen, followed by a second nitrogen. And as we survey the list of molecules that are offered to us, in this case, we've got 3 molecules that meet this criteria. The first one is F. So if we take a look at F, go ahead and draw an F on here. And looking at this molecule as far as how did we get here, was all we did was to push a lone pair of electrons to form a bonding pair of electrons between the 2 nitrogens. And then as if to make room for these incoming electrons, we push this bonding pair here onto the carbon. That gives us a formal negative charge on our carbon. And at the end of the chain here, where we did have a negative charge, this is now neutral, and that middle nitrogen still maintains that positive charge. And you see the charges, the overall charge is still 0. All we did was to push electrons down the chain there. So this takes care of our situation with F. That is definitely a resonance structure of D. The next one up would be I. If we write out the structure for I, it's been flipped around on the problem set. So all I'm going to do is rewrite this structure so that it's in the same sequence we see here. But it's definitely the same molecule. Because all we're doing is changing the electron structure. So as far as how did we get from F to I, well, all we did was to take electrons from this bonding pair and push them onto that middle nitrogen. So now that middle nitrogen no longer has a positive charge, but now the one on the end does. So this has a formal 1+ positive charge, and not shown, we still have a negative charge on our carbon. So we've got that lone pair on our terminal carbon so that it has a negative charge, and this is another resonance structure of that molecule D. Okay, I've tidied up our board up a little here because I want to move on to the last structure, which is K. And again, K's in a situation where they try to, they've got it flipped around, but all I'm going to do is flip it the right way around so that it's showing us the same sequence. And when I do that, in the case of K, here's what we end up with. And you see, our connectivity is the same, so we're meeting that. It's all we've done is to push electrons around. Now, we're going to get into, what makes for some resonance structures being better than others, but to the letter of the law, this meets the criteria of being a resonance structure in the sense that we've got the atoms connected in the right sequence. And as far as how we got here, is all that was done was to push that bonding pair between the carbon and the nitrogen onto this nitrogen, which left this carbon with only 3 electrons. So in terms of its ownership, and it's group 14, so it should have ownership of 4 electrons. And it's we would call this a carbocation, so it's bearing a positive charge. The nitrogen now becomes neutral, and we still have a negative charge on that terminal nitrogen. But this would be K, and this is the third resonance structure in that series that is associated with molecule D.